Morning students. In last class we have done about the classification of elements. As you have got, modern periodic table contain four types of elements. These are S block, P block, D block and A block. S block elements means those elements in which the last electron enters in S orbital in their electronic configuration. They are called S block elements. And in our periodic table, group 1 and group 2 elements are called S block elements because their last electron always enters in S orbital. Now, if you want to know the properties of S block elements, these elements are mostly metals and they are good conductors of heat and electricity. Thirdly, they always have the tendency to form ionic compounds. They mostly form ionic bonds, and ionic bond containing compounds are called ionic compounds, and that is why, since these are metals, so mostly they form ionic compounds. And another property, when you heated this metal in flame, they give some colored flame. Most of the metals except beryllium and magnesium, other elements, the S block elements, other elements can show characteristics colored flame when you burn. Why it happens? Because when you heat it in flame, the valence electron get excited. Due to excitation of electron, you will get the colored flame. So except beryllium and magnesium, other elements of S block elements can show colored flame. Now the second one, which is called P block elements. P block elements means the elements in which the last electron enters in p orbital. P orbital means it may be px, it may be py, it may be pz. Enters in p orbital are called P block elements. In modern periodic table, group 13 to groups 18 contain the P block elements. So 13, 14, 15, 16, 17 and 18. This group contain the P block elements. Group 13 contain boron, aluminium, gallium like this. 14 contain carbon, silicon, germanium like this. Phosphorus. Group 15 contain nitrogen, phosphorus, arsenic, antimony, bismuth like that. Group 16 contain oxygen, sulfur, selenium. 17 contain fluorine, chlorine, bromine, iodine like that. And this one contain neon, argon, krypton. So these are called noble gases. These are all the elements. I have written some of the elements. This group number 13 to 18, they contain these P block elements. Group 18 contain helium also, but helium belongs to S block elements because its last electron enters in S orbital. Other than helium, all the noble gases are said to be P block elements because their last electron enters in P orbital. Now, if you want to write the electronic configuration of boron, you can see boron atomic number is 5, 1s2, 2s2, 2p1. So last electron enters in P, that's why it belongs to P block. If you want to write phosphorus configuration, 15, 1s2, 2s2, 2p6, 3s2, 3p3. Here also last electron enters in P, that's why P block. If you want to write the noble gas configuration, suppose 10, 1s2, 2s2, 2p6, last electron in P. So that is why these are called P block elements. Now, as you know, P contain maximum 6 electron and noble gases contain 6 electron in P, and that is why noble gas is the last one. So since their last electron enters in P, that's why they belongs to P block elements. Now I think you know group 18 elements, these are also called inert gas. They are also called noble gas. Why they are called inert gas? Because they are chemically inert. I mean their reactivity is very less. Why reactivity is very less? Because they contain stable electronic configuration, full-field orbital, and due to presence of full-field orbital, stable configuration, they have no tendency to release or gain the electron, and that is why they have no tendency to form compounds with other elements. You know, to form the compounds, either it should release or gain the electron, but they have no capacity to release or gain the electron because already they have stable configuration, and that is why due to less reactivity of these elements, they are also called inert gas. And this group 17, they are also called halogens. Why they are called halogens? Because actually halogen is one of the Greek word. Halo means salt and gen means producer. Maximum of salt produced by this element, chlorine, chlorine, bromine, iodine, they form maximum of salt. That is why they are called salt producer elements, and in Greek word they are called halogens. You know our common salt. What is the formula of our common salt? Sodium chloride, NaCl. It also contains chlorine. So that is why these elements are called halogens. Group 16s, they are called chalcogens. Group 16 elements are called chalcogen. Why they are called chalcogen? Chalco means ore. You know metal ore. Chalco means ore. Gen means producer. Maximum of metal ores are formed by these group 16 elements. You know metal ore already you have got. Aluminium, metal ore, bauxite. You know what is the formula of bauxite? Al2O3. I mean with aluminium oxygen is present. That's why oxygen is one of the ore forming elements. You know lead or zinc ore, zinc blended ZnS. Sulfur is present with zinc. So maximum of ore you will get from this group 16 elements. I mean they are ore producer elements, and that's why in Greek word they are called chalcogen. Chalco means ore, gen means producer. And group 15, since the first element is nitrogen, that's why they are called nitrogen family. 14 group elements are called carbon family, and 13 group elements are called boron family. Now in the electronic configuration, what is the valence shell configuration of boron? You know 1s it is present in first cell, 2s and 2p they are present in L cell. I mean here L cell is the valence shell. In phosphorus 1s is present in K, 2s 2p they are present in L, 3s 3p they are present in third cell M cell. In case of neon 1s is present in K, 2s 2p present in L cell, I mean second cell. Now you have seen boron valence shell configuration 2s to 2p1, phosphorus valence shell configuration 3s to 3p3, neon valence shell configuration 2s to 2p6. I mean every element contain one s orbital and one p orbital in their valence shell, and since the principal quantum number is same for both s and p, that is why you can represent them like this, ns and p, and every element contain ns2 configuration, 2s2, 3s2, 2s2, like this. Every element contain 2 electron in s, and in p it may be 1 electron, it may be 2 electron, it may be 6 electrons, so you can write 1 to 6. So this is the general valence shell electronic configuration of p block elements. The general valence shell electronic configuration of p block elements are this one, ns2, np, 1 to 6. So this valence shell configuration is very important for exam. Write the valence shell electronic configuration, general valence shell electronic configuration for p block elements. Then you have to write as ns2, np1. If it asks for boron, then just to write 2s2 to p1. If it asks for phosphorus, 3s2, 3p3. But for general one, you have to mention as ns2, np, 1 to 6. Thank you.